drive shaft.
Welcome back. We start this episode right where we left off in the last one, with me creating a set of wooden templates for the drive shafts. The ends of the dowel that I was using to make the templates was too large to fit in the minis and micros CV joints, so I had to turn them down a bit in the lathe. If you're creating a template for a drive shaft and the dowel that you're using is undersized, one trick you can do to get it to the correct size is to wrap the ends in masking tape. It's usually soft enough that it will push into the spines of the CV joints. For those of you who've been watching so far and thinking that this is one big elaborate joke and I'm about to pull out a lovely set of machine drive shafts, yeah, I'm sorry to disappoint, but we are genuinely going to cut and weld a set of shafts together. Now, it's obviously very tempting just to measure between the inner and outer CV here and hack my drive shafts in two, but before we do that, there's one last little bit of maths that we need to do. Now, there are a number of ways that I've seen drive shafts cut and welded together. The first is very simple. Take your two drive shafts, you butt them up, you slightly bevel the edges, and then you weld them together. The art of keeping your drive shaft balanced as possible is to keep them as concentric as possible. Theoretically, if something is perfectly symmetrical, then it will not be out of balance. Now, because of the way we're going to join them, and because we were unlikely to get them absolutely perfectly balanced, then this is unlikely to happen, and is why I'm not going to be driving my drive shafts this way. The next, to keep them concentric, is to cut two drive shafts, put them up, and then weld a piece of pipe over it to keep them concentric. I'm applying a fillet weld here, 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 and here. It can also be a good idea to through drill the sleeve or pipe that you're using and rosette weld there, there, and on the other side. Now again, I'm not a big massive fan of doing it this way purely because those holes on where you weld will not be perfectly symmetrical. So again, it's potentially going to be slightly out of alignment. Albeit this joint is stronger than this one. So this brings me on to the third way, and the way I've joined drive shafts before, which is to do this. By joining drive shafts this way, we have a mechanical key between them, which doesn't require us to put the rosette weld in the through holes as we've done here. I will, however, though, still sleeve this. But instead of just using a simple piece of pipe, I'm going to machine an accurate sleeve in one piece on the lathe. And then we will set this back up in the lathe, getting it as concentric as possible. And fillet weld there, there, and there. What we do have to be careful with this, though, is the lengths that we cut the two halves of the drive shafts to, because we have to take this key into consideration. The join in the drive shaft will actually be there, and I found typically the distance here wants to be half the diameter of the larger of the two shafts. Now the mini shaft and the micro shaft are actually very close in size and diameter, so this makes this quite easy. They're both about 1 inch on diameter, so that will be ½ inch, and from the center line to the end of one drive shaft will therefore be 1/4 inch. What this means is that whatever the length that we measure from the outer to the inner CV, it is half that distance plus 1/4 inch. With the length of the drive shafts worked out, it's finally time to cut up some drive shafts. Now if you're going to build drive shafts this way, don't even bother attempting to cut them with a hacksaw or a bandsaw, they're just not going to touch it. Due to the materials that the drive shafts are made from, an angle grinder really is your only option.
Once you have one shaft cut and notched, it's just a case of repeating it 3 more times.
They require a little fettling, but I'll do that after I've machined the sleeves and make sure they are concentric. Who's up for trying a series in a micro?
When machining sleeves for the drive shafts, you want to make them as accurate of a fit as possible. This means that each sleeve should be machined for the cut drive shaft that is going into it, and not just a nominal value. When you measure your shafts, make sure they're as clean as possible and do not have any form of coating on them. Prior to machining the sleeves, I put each of the cut drive shafts in the lathe and ran some emery paper down them until they were shiny. This also gets them prepped for welding. One final thing, when machining the sleeves, all turning, drilling and boring must be done in one go without removing it from the lathe. As soon as you remove it from the chuck, you will lose your concentricity and therefore introduce imbalances into the shaft. The use of the rolling centre helped keep the part steady in the lathe while it was being machined. This helped keep the part concentric and therefore balanced. I machined the sleeves so they would have a minimum of a 5mm wall thickness. For the mini and the micro drive shafts, this meant an overall sleeve diameter of approximately 35mm. With the centre drilled out as large as I could go without going oversized, the next step was to use the boring bar and machine the sleeves up to the correct size. With the final cut done and the sleeve not being taken out of the lathe, the drive shafts were test fitted. The drive shaft that goes in from the other side was test fitted by passing it all the way through. By test fitting the shafts into the sleeves while it's still in the lathe, it remains concentric, and if necessary you can open them up a bit. First of all, you might notice the rather casual shirt I'm wearing, and second of all you might be wondering why I didn't part the sleeves off in the lathe. This is because the sleeves took so long to machine I had to go back into work on my day off to finish them, and due to the weight of the sleeves, if I parted them off I would have most likely broken the parting off tool.
So once again we've ventured out to the Project Peddler Skunk Works, and this time we're welding drive shafts. Now I'm not going to go into all the reasons of why we haven't used this lathe to machine the collars. What I will say though is the lathe that you saw when I did machine the collars, I can't weld at that location. So the idea is that we set up the two halves and get them as true and concentric as we can using a dial indicator, and then my dad is going to very carefully rotate the lathe over by hand as I TIG weld around the joint.
Okay. It's okay, stop. Okay. Okay. Yeah. Okay. Okay. Yep. Yep. Okay. 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 Right, just there, hold there a second then.
Is it? That's all the way around.
Oh. Oh gosh.
Don't touch it.
Good gracious. That is hot.
Once the drive shaft had cooled down, it was just a case of turning it around, aligning the opposite side using the dial indicator, and repeating the welding process 3 more times. Now drive shafts are welded, we'll clean these up, get a coat of paint on them, and then we can reassemble them. Obviously we don't want paint on splines at either end because it's going to interfere with the CV joints, so we are going to mask them up. With the drive shafts cleaned and masked up, I gave each of them a coat of etch primer, followed by a coat of satin black. Well, I've got a whole load of parts here and the necessary tools, so we've just got to put the drive shafts together. Now it's especially important, as we've got the sleeve in the middle of this drive shaft, to remember to put on your CV boots first before trying to fit the CV joints, as there's no option of sliding this on from the other end. Obviously when you put the second one you lose that option anyway, but yeah, I don't want to have to go knocking CV joints out on again because I forgot a part. Now fortunately my original CV boots here are actually in quite good condition, and as I really don't want to have to go in the shop and buy more, we are going to reuse them.
use these solid rings that are kind of a bit of a press fit on the outer gaiters. You can't use this kind of style because the little bump that you get there gets caught on the inside of the hub, and as it rotates it will knock them off. That's why it's pays is to try and be as careful as you can with these, and I think when you take them off so that you don't distort them too much or stretch them, so you can get them back on.
I'm going to end the episode here. The drive shafts and the suspension will be fitted at a later date. If you've enjoyed this episode, then please hit that like button and share. If you want to keep up to date with the build, then please subscribe to my channel, and you can follow my build thread on the mini forum, to which the link is in the description below. Come back next time when we start tackling the job that seems to strike fear into custom car builders everywhere. That's right, we're tackling the wiring. Once again, thanks for watching.